my roommates. So in the real world, assuming you like milk, how do you solve this problem so that you don't end up with twice as much milk as you care to have? Yeah?
Put a note on Put a note on the fridge.
What, put a note on the fridge, right? You put a Post-it note on the fridge saying, gone for milk, right? And so that should hopefully provide your roommate with a clue. It should lock them out effectively of actually inspecting the state of this world and misinterpreting what the outcome should be. Or you could literally, if we want to borrow database terminology, you could lock the fridge, right? You could padlock it so that they can't even see inside of the refrigerator. So it turns out in databases we can do exactly this sort of thing. Consider the following code that you might have used in a SQL query for, say, CS50's problem set 7, if you did that one. So you may recall for CS50 Finance, we wanted to enable users to buy shares of stocks, but sometimes the user might reasonably want to buy more shares of a stock. Now, what might happen in this situation is a little worrisome, and so we just kind of told you in 50 blindly, just use a query like this and bad things won't happen. Well, now we're talking about the bad things. This query is atomic, which means that it will either all execute or not at all. It will not be interrupted by any other SQL queries that touch that same table, which in this case is called table. So what does that mean? Well, this query, as you can kind of infer, it's going to try inserting into the table an ID, symbol, and shares, those 3 specific values. But if there's a collision, in other words, if there's already a row in the table for user ID 7 trying to buy that penny stock AFLB-OB, well then it's instead going to increment the number of shares by this amount, which in this case is going to be 10. So in other words, you kind of do want that to happen all at once. You want to either insert that new row or update what's there, but you don't want something to happen in the meantime. Why? What might happen if you did this kind of update with multiple queries and not this one-liner, which happens to wrap onto 2? Yeah?
So between when you get the number of shares that they have and inserting the new number or updating the number, they could have bought something or sold their shares. So it decreased in between, but you still incremented the original value?
Perfect. Right. So if you broke this up into multiple queries, your first query might be select. Select the number of shares that this user has for this penny stock. And suppose that number is 12. Well, then in your next query, you might say, oh, well, I got rows back, which means they already own this stock. So let me do an update where I change the value of that row to be 12 plus whatever the number of shares is that they want to buy, 10 in this case. So 22. But what if, just by bad luck, that same user, or maybe a malicious user with multiple laptops or multiple ATMs, is trying to create a situation in which the queries get interwoven? So I check and I see I have 12 shares. But suppose in the other window, the user happens, or in a separate browser tab, they happen to buy more shares or sell some shares. So the number of shares they actually have is actually no longer 12. And then that thread gets suspended, and the original thread does 12 plus 10, giving me 22 shares. That might not be the correct answer anymore. Because when I check the refrigerator, the state of the world subsequently changed because I didn't block out all other roommates or all other threads. So we need a way of solving this. And the brute force way of solving this is just to say, stay out of this table. Right? You can literally padlock the refrigerator, or you can padlock the MySQL table, and you can say no one else can write to this table at this moment in time. How do you do that? Well, these are just 4 SQL queries back to back. You could execute these at the blinking black and white prompt at the terminal window in MySQL, or you could implement them with PHP's MySQL_query or with CodeIgniter's query method. But in short, you specify lock tables, the name of the table you want to lock, which let's call it account, come back to the money example, for writes. So you don't want anyone else to write to this table. If they read, fine, whatever, but writes are the dangerous one because they can change the state of the refrigerator. Next, I do select balance from account where number is 2. So account number is 2. So give me account number 2's account balance, and then go ahead and update the account, setting the balance equals to 1500 where number equals 2, then unlock tables. So ignore or just assume that we care to do 1500 for some reason, though there might be some logic in PHP code intermingled among these 4 lines. But the point is that lines 2 and 3 will execute together or not at all. They cannot be interrupted. But logically now, what's the downside of this solution to this problem of what's called a race condition, where both you and your roommate, so to speak, are racing to get milk and your operations are overlapping? Yeah?
Well, if someone else wants to write to a different record, then they'd have to sit there waiting.
Exactly. So we may be updating record number 2, account number 2 in this case, but there could be hundreds or thousands of other accounts in my bank system. And this, unfortunately, with my ISAM tables and with locks, you're literally shutting everyone out. Now, if you don't have a popular website, not a big deal. But if you do have hundreds or thousands of transactions per second, which is not uncommon on the web today, well, you're really going to impede your performance. This is a huge bottleneck that everyone then has to go through. But you now don't run into a situation where account balances are incorrect. What's other downsides? Yeah?
You could run into a deadlock. So for example, let's say your account balance of 200 depends on the result of some other database query that needs to write to tables or something.
Perfect.
Then that query needs to execute first, but you've locked the tables, and so now you're stuck.
Perfect. So you can find yourself in situations, the general topic is known as deadlock, where both people are waiting for the refrigerator to be open. So both you and your roommate are stupidly standing there because the note is there somehow, and you got yourself into a situation where you didn't... I'm pushing the analogy a little too far now. But that would be the physical incarnation of deadlock, where you're both waiting for the same resource to become available for some reason. So in short, this is a very heavy-handed solution, but there is a more fine-grained one if you ditch my ISAM and use InnoDB, which again has become the default for MySQL anyway, but you do give up some things. A little bit of performance in some types of queries, but more relevantly to before, full-text queries go out the window. You can't use them for that. So in InnoDB tables, you don't say lock anymore. You instead say start transaction. This has some synonyms. You can also say begin or a couple other things, but start transaction is the proper SQL way. So here we're doing update. Suppose the following scenario happens. Update the account, set my account balance to balance minus 1,000 where the account number is 2. And then update this other guy's account balance to plus 1,000 where account number is 1. In other words, transfer $1,000 from this account to this account. Kind of ideal if these two transactions are not interrupted, right? So that the money actually exists when the transfer happens. So how can we do this? Well, with transactions, we can actually do not only updates and inserts, we can do selects, check the value to see if something bad actually happened, and then only commit the transaction if everything is good. And by this I mean the following. Start transaction. Let me go ahead and update the account, setting the balance equal to balance minus 1,000 where the account number is 2. So in other words, debit $1,000 from this account. Then go ahead and add $1,000 to this account, account number 1. And then let me do a sanity check. And there might be some PHP code intermingled here. We're just looking at the SQL queries, top to bottom. Select the balance from account where number equals 2. If I detect in my PHP code that the value I just got back is actually negative, this is bad, right? Something bad has happened. I've tried debiting more money than this person has. So what do? Well, thankfully, with transactions, you can literally execute the SQL query rollback, which will undo everything you just did up until the point of start transaction. The only exception is things like drop table, drop database cannot be unrolled, but you should not be doing that programmatically anyway, right? So in this way, you can ensure effectively that all 4, or really all 6 of these queries are executed all at once or not at all. You won't get your database into some inconsistent state. So what's the takeaway here? Anytime you have tables, especially multiple tables, where you might need to update 2 things at once. I need to remove some money from this person, add some money to this person. The problem is that, again, if those same rows are touched by a different thread, whether accidentally or maliciously by an adversary trying to create this race condition, you don't want to end up giving someone more money or less money than they're actually owed. So let's go ahead and let's see if we can see this here. Let me go into the appliance. Let me SSH to, all right, here, Crimson, so MySQL-U, jharvard-p, jharvard_lecture 2. All right, so now I'm logged into the database at a blinking command prompt here. And let me go ahead and open up a second window. We'll move it over here, SSH to the same system. Let's do MySQL-U, jharvard-p, jharvard_lecture 2, Crimson. All right, so now I'm connected at a MySQL prompt. So this is essentially like the non-graphical version of PHP-MyAdmin. So let me go into PHP-MyAdmin, and just for the sake of discussion, let me go ahead and create a table called, let's say, cache, and 2 columns. So this will be the user ID, and this will be the amount of cache that he has. So we'll just do an int. We'll do a decimal, which a decimal, recall, is a very precise number. It can have, let's say, 65 numbers and two numbers after the period. This will be a primary. And this will be, whoops. OK, so now I have this cache table. So now, if unfamiliar with the command line, notice that I can do the following. Show tables, semicolon. This shows me exactly what's in my tables. If I do, let's say, select star from cache, I get an empty set. So suppose I want to do this. Insert into cache, let's say ID cache, let's say user1 is going to get, let's say, $100. All right, and then user 2 will get $200. All right, so now select star from cache. OK, so that's correct. And now let's go ahead and do this. Start transaction, semicolon. If you see the arrow, it means you forgot the semicolon, like I just did. All right, so now let's go ahead and say update cache set cache equal to, let's say, how do I want to update this? Let's go ahead and cache equals cache minus 100, where ID equals 1. But meanwhile, that thread got suspended. So my alt tabbing is equivalent to that thread being put to sleep for whatever accidental operating system reason. So now I'm going to go here and just do select star from cache. All right, so that's good. So now let me go ahead and do update cache set cache equal to cache minus 100, where ID equals 1. So what is this? You can think of this as the Bank of America's implementation of their ATM. Right? I'm at an ATM. When I say give me $100 out of the machine, and after typing my PIN, this is the query maybe that's executed. By default, queries in MySQL are auto-committed. So we've had this notion of commit all this time. It's just they've all happened automatically. Every query is auto-committed. But if I do this now, it is indeed executed. So now select star from cache. And he has $0. So now let's go over here and hit enter. OK, so that's good. Select star from cache. So this is the other ATM machine if I'm kind of like tag teaming on two different side-by-side ATMs here. OK, that's bad, right? So that should not have been allowed to happen. But hopefully, if Bank of America implemented their ATM correctly, they have executed, after the update, a select, doing a sanity check. Has it gone negative? Because if so, damn it, we don't want to give this guy his $100, so we better not commit this transaction. Let's instead do roll back. OK, now let's reselect the table, and it's back to 0. So even though that was a simple one query, we could have rolled back a dozen queries in this way if we wanted to. So any questions on what problem we're actually trying to solve here with transactions? And for those who don't want to raise their hand, oh, yep. Sure.
Because CodeIgniter has its own syntax for querying, is there some sort of way we can do that within CodeIgniter without having to do regular PHP, like start transaction and transition CodeIgniter syntax and go back for all that?
A good question. So CodeIgniter does support transactions by way of a PHP method call. To be honest, your TF might disagree. I am underwhelmed by CodeIgniter's MySQL or database library. To me, it's just rewriting what is raw SQL queries anyway. Frankly, I think doing something like this is very reasonable in CodeIgniter, where you do your own SQL queries in the actual query method, and in this way could you then execute begin transaction yourself, roll back yourself. So you can use the MySQL library. I've just been unimpressed with it. Doesn't really do anything for me other than force me to learn their syntax. Plus, it's easier to express, I think, more sophisticated SQL queries if you're doing it yourself. Other questions? All right, so PDO. So on top of what CodeIgniter is actually doing is, even though we configured it for a MySQL database, it actually can support any number of databases. And MySQL is just one of them. Could use Oracle, could use Microsoft Access. And that's because CodeIgniter does not use MySQL underscore whatever. All of those functions we've typically used in CS50 are obviously tied to MySQL as per their names. But this isn't the best design, right? If your website's getting popular and someone decides, well, we really need a bigger database, although frankly MySQL does scale quite well, but someone decides that you need to change the database database backend, it's kind of unfortunate if you have to go through and change all of your function calls throughout your entire program just to change your database. So a recurring theme already in CSS, in today with views and whatnot, has been abstracting away some of these details. And so PDO is actually the library used underneath the hood in CodeIgniter to create this abstraction library. So what does this mean? PDO is Portable Data Objects. And this just means it's a more generic library that has support for fetching data, for selecting, for inserting, for updating, for transactions, but it's independent of MySQL. It converts the commands to Oracle or to MySQL